This training video will focus on placing a ditch or cut at the base of fill in road design, and will specifically focus on doing so only when the cross-section is running uphill. It's a very special condition, and we want to show how this is accomplished. So what we'll do is we'll look in on our short little alignment that we're using as an example. We're in RoadNet, and we're going to examine the template. We'll double click and look at the template, and we'll look at the fill icon here, and you'll see that on the right hand side we're actually treating left and right differently, although there is no fill on the left, as it turns out. We are looking at the ditch condition. We're going to force a ditch whenever the fill is less than 40 feet at the base of the fill, but now we're going to click on only in the uphill cross-section condition. So we accept that. Let's take a quick look at the cut, because this is going to be important. When you're forcing the ditch, it uses the cut defined within the cut icon, and you can see it's at -3:1, 6 feet horizontally, which would be a 3:1 slope, 2 feet down, and then it comes up at 2:1. So the ratios are different coming out of the ditch than going down to the base of ditch, where the ratio is more gradual. Hit OK. You'll see this come into play. And we will exit. We haven't changed anything. We've just observed. And we're going to output Road 2 existing, Road 2F final. We will hit OK and process this out. Now we will go and look at our sections. Input edit section file. We're going to bring in the final and reference the existing ground. And we'll start at the very beginning. We'll look at 0, and you can see that we have a 3:1 slope on this side. We have our 3:1 ditch over here, and then our 2:1 coming out of the ditch, catching left. Now we're going to hit OK and move down to station 2 plus 0, 0. And you see the ground still is running downhill in the fill condition. You can see our break in high side super elevation. The program will calculate these interesting catch points on the right hand side, which are very difficult to calculate by hand. 22.687 is the offset for that particular catch. And these are all available in the final cross-section output. Let's move down to 4 plus 0, 0. And the ground is flat. We still don't get a ditch on the fill side. Now let's move down to 450. And you can see we've caught the ground, and it's 2:1, 3:1, and 4:1 in the fill slope. Why? Because the fill is under 4 feet, and there's a rule in the fill condition that under 4 feet go 4:1. So that explains the multiple slopes involved here. But notice, because the ground's going uphill, the ditch is applied to the fill condition, and it's true at the very last station as well. This last station is interesting because it illustrates that we were very close to where the subgrade itself might have been under the ground, in which case the green subgrade needs to go vertically so that subgrade is not placed below a actual existing ground outside of the daylight point. So there's an example of the application of uphill only.